We're going to skip over chapter 10 for now. We're going to come back to it after we do 2 sections in chapter 11, because that way I want to go straight into what we've already been doing, quadratics, and kind of get that penultimate quadratic work that we're going to be doing, which is going to be dealing with quadratic and their graphs. We're going to be focusing on graphing quadratics through what we call transformations. So we'll be looking at the parent function and making adjustments based on how the equation looks. So, back in chapter 3, when we first started looking at quadratics, we looked at a couple of different things with our standard form. We noticed that the leading coefficient, the a value, determined whether or not our parabola opened up or down. Okay, so recall that if I had a leading coefficient that was positive, my parabola opened up. If I had a leading coefficient that was negative, my parabola opened down. The highest or lowest point of the parabola is called our vertex. When my parabola opens up, my vertex is a minimum value. When my parabola opens down, it is a maximum value. We also have the axis of symmetry, this imaginary line that runs through the vertex, and it creates a mirror image on both sides of that axis of symmetry. So when we're graphing a quadratic, all we really need is one half of the graph, because then we can use the symmetry of the axis of symmetry to fill in the other half of the graph. So it kind of cuts our work in half for us. We're going to look at 4 different transformations today. The first one is called a vertical shift. A vertical shift. When we have something being added or subtracted to my quadratic after the x is squared, okay, after the x is squared, we have a vertical shift. It's going to take all those points on my quadratic and either move them up or move them down. If I'm adding, I'm moving all the points up. If I'm subtracting, I move all the points down. So you'll see all the y values change relative to your parent function. Your vertex will also move. So we want to always track our vertex first, figure out where our vertex is, and then kind of map some points around that afterwards. So our vertex is at 0, and then whatever that vertical shift is. The axis of symmetry isn't going to move, so it's going to stay on that y-axis no matter how much I move up or down, because that middle point isn't changing. So we're going to start with f of x, our parent function. So let's look at f of x. We're going to do some tables of values, but as you become more adept at the transformation, you won't have to do those tables. You'll be able to track where these points are moving and graph them without having to do any additional calculations. But we need to know where to start. So we're going to use the points -2, -1, 0, 1, 2 for our x values on our parent function. And then those points are going to move based off of the transformations. All right? So if I plug in -2 and I square it, what do I get? 4. If I plug in -1 and square it, what do I get? 1. What about 0? And 1? And 2? All right? So if I plot those points, we see that we have here, 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 and here. There's our parent function. There's our parent function. All of our transformations are going to be based off of those 5 points. That's our starting. Everything's going to be based off of those 5 points. Okay, so to start, note that a is 1. Okay, my leading coefficient is 1. Which way does my parabola open? Up or down? Up. Where's the vertex? Say again. 0, 0. Vertex is always an ordered pair, must be listed as an ordered pair. It is at 0, 0. Where's the middle of my graph? On the y-axis. X equals 0. axis of symmetry is always an equation. X equals, and it's whatever the x value of your vertex is. So the x value of your vertex changes, your axis of symmetry is going to change. Now, let's graph g of x next. Okay, so let's add in g of x. Okay, so same idea. I'm going to take -2, I'm going to plug it in, I'm going to square it, but then I have to make it negative afterwards. So what's -2 squared? What's -2 squared? 4, and then make it negative. What do I get? -4. So what happened when I went from f of x to g of x? It made it negative. Okay, let's do it again. -1 squared is what? 1. Make it negative. Made it negative. 0. That'll still be -1 because 1 squared is 1. Make it negative. -1. 2 squared is 4. Make it negative. -4. So now I have those new points here, 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 and here. What happened to my graph? I flipped it. Now it's opening down. We call that an x-axis reflection. X-axis reflection. Okay? That is g of x. All right? What caused that is the negative sign. That negative on the leading coefficient gave me an x-axis reflection. It flipped my graph upside down. Okay? Vertex, did it move? Or is it still at 0, 0? Still at 0, 0. Okay? It's still here. But now it's a maximum instead of a minimum. So my vertex is still at 0, 0 for g of x. Okay? Axis of symmetry, did that move? No. Still at x equals 0. Okay? It didn't move. Now let's move into h of x. Okay? So when we had our parent function with f of x, all we had to do is just take our y values, make them negative. So let's look at what h of x is going to do. So I'm going to plug in. I'm using still -2 is my x value. So -2 squared is what? 4 plus 3 is 7. -1 squared is plus 3 is 1. Squared plus 3. -1 squared plus 3, 4. And 2 squared, 7. So now I've got my new points. -2, 4, 5, 6, 7. -1, 4. 0, 3. 1, 4. 2, 7. What happened to my graph? It went up. How far? 3 spaces. Notice, what's the difference between this y value and that one? It added 3. What about that one and that one? And that one and that one? And that one and that one? And that one and that one? So we take the y value of our parent function and just add 3. Take the y value and add 3.
So h of x is just that.
And 3 to the y value.
G of x is just making
G of x is making the y value negative.
So if it was negative,
But still goes up.
Say again.
so if somehow positive 4.
What does that say at the bottom? X1?
X equals 0.
Oh, XX.
So if we had, if this was negative here,
No, it's f of x. I don't know how.
yeah, I mean, if f of x was negative, then it would just mean our function is negative, so it would be upside down here. Just flip it upside down there. Take that back to being positive. All right. So now let's look at j of x. So let's use some inferencing, so we don't even have to calculate. Okay. If h of x was adding 3 to my y values in order to get my new points, j of x is going to do what to the y values? Subtract. So what's 4 minus 3? 1 minus 3. 0 minus 3. 1 minus 3. And 4 minus 3. So once you know those transformations, you can take the 5 values that legitimately you should memorize for our parent function. I mean, they're quick to get. 0 squared, 1 squared, 2 squared. All right? Take those y values and either add or subtract to move it up or down. So we have our new points at negative 2, 1. So negative 2, 1. And 1. Oh, that's up here. I'm losing my mind. Ignore that one. Where am I at? Negative 1, negative 2. 0, negative 3. There we go. Much better. Ignore that one. So I took it, and I took all of these points, and I moved them down 3 units. Every single point from my parent function went down 3 units. Okay? I forgot to do vertex and axis of symmetry. What's my vertex for h of x? It's an ordered pair.
Oh, sorry.
0, 3. What's my axis of symmetry? Still x equals 0, right? Okay, what about j of x? What is my vertex? Good. And the axis of symmetry? I don't know why. X equals 0. Okay, so my axis of symmetry didn't move because the middle's still on the y-axis. But my vertex shifted up and down based on how far it moved, up or down. So second type of transformation is a horizontal shift. What does horizontal mean? What directions? Left and right. Okay, so horizontal shift means we're moving left and right. Compare that to our vertical shift, how these look different. That's a horizontal shift versus our vertical shift, which was x squared plus k. It's in the parentheses. We have a different variable. What else? And it's subtracted. Okay? So when we have a vertical shift, we're taking our y values and we're adding or subtracting them. On a horizontal shift, we're taking our x values and we're adding or subtracting them. So our x values are going to change before we square it. Now, because we're doing it before it gets squared, it has this weird backwards effect. Okay? Meaning we have to have a higher or lower number in order to get back to the same value that we had originally, which is why now the formula has changed to a minus. That minus means it's going to have an opposite effect of what you think. If I say to add something, it makes sense to go up, right? And if I say to subtract something, it makes sense that it goes down. To do the opposite. Okay, so if I'm adding something, instead of moving to the right, which would make sense, I need to do the opposite. I need to go to the left. And if I'm subtracting something, it's going to move to the right.
And this is just x-axis?
It's just x-axis. Yep. So x-axis, horizontal shift. Subtracting, we're moving to the right. Adding, we're moving to the left.
Why is y-axis the same?
Because what we're doing is we're changing the x value before it has a chance of being squared. So what it really comes down to, if I had more time to go into more detail, I would. But the gist is, I have to have a larger x value in order to still get the same y value because I'm subtracting first. Okay? So what we're going to do is we're going to look at tables for f of x and g of x, and we'll compare them to see why that ends up being the case. All right? So if I start with f of x and my x values, okay, my starting points are negative 1, 1, 0, 1, and 2, okay, to give us 4, 1, 0, 1, and 4. Those are my parent function values, okay? So let's compare them. If I use the same x values for g of x, if I plug in negative 2 and I subtract 3, what do I get? Negative 5. And then I square it, what do I get? 25. Can I fit that on my graph? No, that's way up there. Okay, what about negative 1? Negative 1 minus 3. -4. And then I square it, 16. Okay, still way above on my graph. Let's try 0. 0 minus 3. -3 squared, 9. I'm getting closer. It's coming down, but I'm still way up here. Okay? It's coming down, but I'm still way above on my graph. All right? So now we do 1. What is 1 minus 3? Square it. 4. Yeah, I need to finish squaring. Okay? So now I'm finally at a y value of 4. When here I started a y value of 4 at -2, I had to make my x value 3 numbers larger just to end up at the same spot. I had to make my x value 3 digits larger to end up at the same spot. Which is why we have to move the opposite direction. Okay? So that was 1, 4. Now let's do 2. What's 2 minus 3? 1. Square it is -1. But square it, you get? We get 1. So now I'm at 2, 1. So now we have to add some more values in. So we got to keep going to the right. So now let's do 3. What's 3 minus 3? 0. And then square it. 0. And then 1. 1 minus 3. Or not 1, 4. I'm in the wrong direction. 4. 1. Square it is 1. And now we see that turning point, and we get that symmetry. And then if I plug in 5, we get 4. So for x minus 3, which direction did my graph move? Because I had to increase my x value by 3 just to end up at the same y value, because that squaring effect makes it so much bigger, so much faster. Okay? We saw that if we used -2, I ended up with a much larger x value. So we have to increase our x value in order to get back to the right spot when we're subtracting. So everything moved to the right 3 units. What's the new vertex of g of x? 3, 0. Where's the axis of symmetry? X equals 3. So when we do the horizontal shifts, those move. X. Okay? So new vertex, everything shifted right 3 units. Right 3 units. So now let's do h of x. Let's use some inferencing now. Since we know that x minus 3 took all of my values, my x values, and moved them right 3 units, what is my x plus 3 going to do? Move to the left. So, instead of having the point -2, 4, in order to have the same y value, I need to subtract x by 3. So I'm going to have -5, 4. Everything moves to the left 3 units. 1, 2, 3. My x value changed. My x became -5, 4. Y value stayed the same. My x value I had to subtract by 3 so that I end up at that same spot. Instead of having -1, 1, I'm going to have -4, 1. I'm changing the x value on that parent function ordered pair. 1, 2, 3. To get -4, 1. Instead of having 0, 0, it's going to be -3, 0. Everything is moving 3 places to the left. Instead of having 1, 1, I'm going to have -2, 1. Instead of having 2, 4, I'm going to have 1, 4. Those are going to give me my new points. So when we have that horizontal shift, or -1, 4, yeah, sorry. -1, 4. So here and here, everything moved 3 units to the left. So the x value is what's changing on those ordered pairs. When we have plus and minus k, we're changing the y value, adding and subtracting. When we have x minus 8, we're changing the x value on those 5 original ordered pairs. That's what we're looking at. New vertex, -3, 0, and axis of symmetry, x equals -3. So now let's put them together. Okay? Both together. So now we have our vertex form. It's actually standard form, but we've been calling general form standard form, so I'm going to call standard form vertex form. The nomenclature on quadratics is really annoying to me, but whatever. So we're going to have that same U shape of our parabola, but now we're doing shifts left and right and up and down. The vertex is going to be identified with, in our equation, we're going to have a sign switch on H, because if I have plus, I move to the left. If I have minus, I move to the right. So we're going to have that sign switch on H. But K will be the same. The vertical will be up or down. That part makes sense. You just have to remember X values are opposite. Your X values will be opposite movement. And then again, vertex and axis symmetry are always going to have the same X value. Okay? So let's look at f of x and g of x. We're going to graph these two. My parent function, 0, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Okay? So those are my original ordered pairs. I've got negative 2, 4. I've got negative 1, 1. I've got 0, 0. I've got 1, 1. And 2, 4. Okay? So let's look at how these shifts are going to affect our parent function. So this negative 2 moves me which way? To the right. How far? 2. Is that going to change the x value or the y value? Yeah. Because negative 1 squared is 1. Okay. So I'm going to change the x value. I'm going to be moving right 2 units, which changes the x value. So I'm going to treat every single one of these x values, I'm going to add 2. Okay? So, negative 2 plus 2. 0. Negative 1 plus 2. 0 plus 2. 1 plus 2. 2 plus 2. Those are my new x values. Moved everything to the right 2 units. What's that 4 going to do? Going to go up. How far? Up 4, which is going to change my x or my y? It's going to change the y. The y value. Okay, it's going to change the y value. So I'm going to take each of these y values, and I'm going to add 4. Okay? Well, what's 4 plus 4? 8. What's 1 plus 4? 0 plus 4. 1 plus 4. 4 plus 4. There's my new y values. Right 2, up 4. Okay? So, 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 2, 4, 5. 2, 4, 3, 5, and 4, 8. Everything moved to the right and up. Right 2, up 4. Okay, so knowing how those affect your ordered pairs. Inside the parentheses is changing your x values before it even gets a chance to be squared. So that's going to change those x values for the transformation. On the outside is changing the y values. Okay, changing the y values. Now let's add in something else. So, parent function again. What are the 5 points on my parent function? 5 points that we've been using over and over and over for our parent function. Okay. What's the y value for negative 2? Negative 2 what? Is 4. Negative 2, 4. Negative 1 what? 1, 0, 1, 2. Okay. You need to know those 5 points. all of our transformations, we're starting with those points. Those are the ones we're going to move. We're transforming those 5 points. It's not that difficult. -2 to 2, just square it. So now let's look at g of x. Okay? Actually, let me list that out. I want to list that out. Let's look at the table. G of x, g of f of x. Let's look at -2, -1, 0, 1, 2, 4, 1, 0, 1, 4. Okay? Now let's look at g of x. So, I'm still squaring, which means I'm going to have these values, but then what am I going to do after I square it to graph g of x? This is kind of our base value from where to start, and then we're transforming based off of those to get our new points. In x and y for these ordered pairs based on our transformation. Say that again? Because I'm going to take -2, I'm going to square it, that's going to give me 4, then I'm going to multiply by 3. Which gives me what? 12. And then I'm going to take -1, I'm going to square it, that gives me 1. And then I multiply it by 3, and that gives me 3. And I take 0, and I square it, that gives me 0. And then I multiply it by 3, and I get 0. And then 1 squared times 3. 3. And 2 squared times 3. 12. Okay? So I took each of these values for f of x, and I multiplied it by 3. Okay? So let's look at what that does to our graph. And that's going to be like way up there. What's that do to the shape of my graph? In which way? Narrow. So g of x made my graph narrower. We call this a vertical stretch. It's a vertical stretch. Okay? What did I multiply by? 3. So it's a vertical stretch by a factor of 3. I took my y values and I multiplied them by 3. The y values and I multiplied them by 3. Okay? So if I want to do h of x, what am I going to multiply my y values by this time? By 1/3. Okay, so again, f of x, I'm going to multiply them by 1/3. Now, I'm going to add in something here just to make the graph of multiplication a little bit easier. I'm going to add in the points -3 and 3. We'll do those instead of 2 and -2. No, because that's going to get us back to f of x. Then I need to multiply it by 1/3 again. Okay? Because we're transforming f of x, not g of x. I mean, it's going to give you the equation. Okay? So, 1/3. So, let's not do -2 because that one's annoying. But what's 1/3 of 1? 1/3. 1/3 of 1 is 1/3. What's 1/3 of 0? 0. What's 1/3 of 1? Okay, now, let's do the -3 and the 3. Okay, -3 squared is what? 9. What's 1/3 of 9? 3. Okay, that just makes it work a little bit nicer than having so many fractions. Take that on purpose. What's 3 squared? Times 1/3. Okay, so now I have the points because I added them in. Do you want to do 1/3 times 4?
No, I don't. I just want to know, like, is this something we do?
I wanted something that would be easier to multiply by 1/3. That's why I picked 3, because when I square it, I get 9. Gives me back to 3. Yeah. 4/3. It's not as easy to graph. This is much easier to graph. Okay? You could still do 4/3 and 4/3. Those are just more annoying to graph. Okay? So, I mean, let's grab them. We got them all now. So I've got -2 and then 4/3. That's right around here. And then I've got -3, 3. And I've got 1 and 1/3. And I've got 0, 0. And then 1 and 1/3. and then 2 4/3, and 3 3. What did that do to my graph? Made it wider, which is a vertical shrink by a factor of 1/3. Vertical shrink by a factor of 1/3. We took all of the y values and multiplied them by 1/3. That's where we get that shrink from. So when we're looking at that, we've added in that vertical stretch or shrink. Now remember, if I have a negative for A, if I have a negative value for A, what does that do to my graph? Flips it upside down. That is a separate transformation from that stretch or shrink. It's the same number attached to it, positive or negative, but the positive and negative tells you which way it opens, and then the actual value tells you whether it's a stretch or a shrink. That's why when we look at the rule, it's the absolute value of A, because it doesn't want to concern is it positive or negative, because that just tells us if it goes up or down. The number itself, though, tells us if it's a stretch or a shrink. If A is greater than 1, like 3, then we're going to have a stretch. If A is less than 1, like 1/3, we're going to have a shrink. Okay? It's going to become wider or narrower from the parent function. So now what we can do is we can take it all and wrap it in together in one thing. We can do all the transformations. So I've got all 4 here. What does this negative do?
Makes it go down.
Makes it go down. So we're going to flip it. We got an x-axis reflection. Flip it. All right? What's this 4 going to do? It's going to stretch it. By a factor of what? Stretch by a factor of 4. Factor of 4. Okay? What's that 2 going to do? Left 2. What's that negative 1 going to do? Down 1. Down 1. Flip it. That's going to give us the x-axis reflection. Okay? So, we're going to start with negative 2, negative 1, 0. Go back, erase that. Or don't. Do it like that. Stupid machine. 0, 1, and 2. Okay? And then our parent function, f of x, gives us 4, 1, 0, 1, and 4. So our transformation. Now when I flip it and I do the x-axis reflection, is that going to change the x values or the y values? If I take my graph that's up here and then I move it down here, the y value. It's going to change the y values. Okay, so notice what it's going to change. That's going to change the y values. When I stretch it by 4, is that going to change the x values and the y values? Which one? X or y? It's going to change the y value because we're making it narrow. We multiplied all the y values by that stretch, right? So when we do the flip and the stretch, we can do those in the same step. We can just multiply by -4 for the y values. Okay? Left 2 is going to change the x or the y? The x. So these change y values. This changes x values. And the down is going to change which ones? X or y? The y. So now what we do is we do our order of operations. Okay? Order of operations says that we do what first? Parentheses. Okay? So that means I'm going to do that shift left first. Left 2. Okay? So it's going to change my x values. So my new x values, 0. Not 1, not 0, not 1. We're going left, so we're subtracting. -4, -3, -2, -1, and 0. So those are my new x values. Okay, that's that part. Done. Okay, now, we move outside of the parentheses. Don't worry about the squared because that tells us just the shape of the graph. It'll give us the U shape. So what's next after we do parentheses? Multiplication. Okay, what am I multiplying by -4? My x values or my y values? The y values. So take each of these y values and multiply them by -4. What's -4 times -4? -16. Did I say negative and negative? Sorry, I meant negative and positive. -4 times +4 gives me -16. Okay? Now, we're going to be changing this again because I still have to do this one. Right?
Why did you put this?
I don't know. Because I'm like 8 steps ahead in my brain. Yeah. -4 times 1. -4. 0 times -4 is 0. 1 times -4 is -4. -4 times 4 times -4 is -16. So now that covers both the stretch and the flip. Okay, that covers the stretch and the flip. So now last thing is I need to subtract. Is that going to change the x values or the y values? The y values. But it's going to be these y values after I did the stretch and the flip. So -1 equals -1 equals -1 equals -1 equals -1 equals -7, and that covers the down. So my new ordered pairs are -4, -17, -3, -5, -2, -1, -1, -5, and 0, -17. So it's going to take my parent function, which started here, okay? It's going to make it narrower. It's going to flip it upside down. It's going to move it left, and it's going to move it down. Let's see if that ended up right. So 1, 2, 3, 4, way down here, somewhere way down there, okay? -3, 1, 2, 3, -5, 1, 2, 3, 4, 5, -2, -1, -1, -5, and then another point way down there. Did that make it narrower? Yes. Did it flip it upside down? Did it move it to the left? Did it move it down? There it is, this graph. Okay, so we can take our original 5 points and apply those transformations in order, and that gives us our new values. Questions, comments, concerns, queries, or? Okay, so for today and tomorrow,